All right, so for our exponential growth, we have the equation A equals P and then 1 plus R to the T power. So we've been using this formula a little bit in our warm-ups. So we're going to go ahead and label the different parts of the equation. So A represents the amount, or the total amount. Okay, P is equal to our initial investment, an initial or a starting amount. So we're going to look at the different examples and we're going to identify the different parts. So the 1 is always there. It's always 1 plus for our exponential growth. And then R represents the rate. And that's a percent that we need to divide by 100. So we always want to make sure that we turn the percent into a decimal. And then T represents time. Time could be days, time could be months, time could be minutes, time could be years. There's a bunch of different ways that we can measure time. We're mainly going to be using years for the examples that we're going to be doing today. So looking at the two graphs, this graph is increasing, so this is the one that represents the exponential growth. Or sorry, this is the one that's increasing, so it represents our exponential growth. And we'll look at exponential decay another day. So Mr. Foster is starting a new job. His salary for the first year is $30,000. He will receive a 5% raise each year after that. Write a formula to define Mr. Foster's salary, S, for the nth year. So we have a couple of different things that we need to highlight. So go ahead and grab a highlighter out of your black caddy. So it says his salary his first year is $30,000 and he will receive a 5% raise. So since it says raise, that means we're going to be using the exponential growth formula. So the raise part tells us that we're going to be increasing the amount of money. So we have A is equal to P times 1 plus the rate to the T power. So how much will Mr. Foster make after 7 years? So we want to find the amount, which is equal to, so P is our initial amount. So we started out making $30,000 the first year. He's going to receive a 5% raise, so we need to do 5% divided by 100. And when we type that into the calculator, 5 divided by 100 is equal to 0.05. And then it says, how much will he make after 7 years? So T will equal 7. So we're going to use our formula. We're going to plug in our 30,000 for P, 1 plus 0.05 to the 7th power. All right, so I type this into decimals. We have 30,000 times 1 plus 0.05 to the 7th power. So our total amount is $42,213.01. Because this 2 would not round the 1 up, it would stay the same. So we're going to go ahead and record our A, our total amount. So A equals $42,213.01. So since we're talking about money, you want to make sure that you round to the nearest whole So 2 decimal places. So this is the total amount that he will make after 7 years. So he started out with $30,000. He's getting a raise. He's going to end up making $42,213 after 7 years. All right. So we're going to skip Janet's example because it says it's depreciating, which means it's going to be not growing. So we're going to skip over to the second example because I see the word increased, which the word increase means that we're going to be using the growth formula. So in 2000, the world population was 6.09 billion. During the next 13 years, the world population increased by about 1.8% each year. Write an exponential equation giving the population y n years after 2000. And then we're going to estimate the population in 2005. So since we know that it's increasing, we're going to use this growth formula. We're going to figure out what P is equal to, what R is equal to, and what T is equal to. And then we'll make our formula down here, and we'll plug that into decimals and find our population. So it says the world population was about 6.09, so that's our starting amount. We're increasing by 1.18%, which I have to divide that by 100. So 1.18 divided by 100 is 0.0118. And then, so in the year 2005, how many years after 2000 is that? How many years? 5 years, right? So 2000, then 2001, 2002, 2003, 2004, 2005. That's 5 years. So we're not actually going to use the number 2005. We just want the number of years. So we're going to use 5 as our T. So we have our amount is equal to our starting population times 1 plus the rate as a decimal to the time power. So we'll go ahead and take a minute to type that into decimals to estimate our population. So I typed it into decimals. I got 6.4, and then this 7 is going to make this 5 jump up to a 6. So 6.46. And we're talking about population, so this is 6.46 billion is the new population. So we're talking about 6.46 billion people is the population in 2005, or the estimated population in 2005.